Hey. In this video, we will be learning about series and parallel circuits. The most importantly, how to differentiate between a series and a parallel circuit, how to calculate the different voltage, resistance, and current for a series and parallel circuit. You will be learning the formulas and the concepts in this video. So hang in there, let's get started. Now, firstly, let's start with the basics, all right? Series and parallel circuits, how do you differentiate between the two of them? All right, here I will do series and parallel over here. Now, a series circuit, if you must know, of course you must know, has, just let me draw both of them first. Okay, I hope you know what the components are. This is a battery, a cell, and this is a resistor. Okay, I'm not going to explain what is a resistor or a cell over here. There will be another video for that. Now, in a series circuit, there is only one pathway for the current to flow. Yeah, you can see there's only one path. Whereas for a parallel, there is more than one path. You see, when the current comes to this point over here, it can choose to go either this way or this way. And the current will usually go both directions unless of course one resistance is much higher. That's advanced level, let's not get to that. And it will come back. So there are two pathways here for the current to flow. Pathway 1, pathway 2. So this is a parallel circuit where there are more than one pathways for the current to flow. In a series circuit, there's only one pathway for the current to flow. Now this is the simplest way to differentiate between a series and a parallel circuit. Now, how is it that now that you know the series and you know how to differentiate, how can you go about calculating the resistance, voltage, and current? Let's do that right now. So in a series again, and this is parallel. And let me just quickly draw. Okay, so I've got the different resistances there. Now, firstly, oh, I forgot to add. This is, let's put it VS, this is VP. This is voltage for series, this is voltage for parallel. Yeah? Now, the first thing, let's look at the voltage, which is also called the potential difference. You should already know this. If you see potential difference, it's basically asking for the voltage. I will not get into the science of what is the potential difference. That again will be in the current of electricity video. Yeah. So now, here you must know that the voltage across R1 is equal to the voltage across R2, which is equals to the voltage of the primary source. Okay, the voltage, so if I put a voltmeter here, V, I put another voltmeter here, I put another voltmeter here, all the readings will be the same because this is in a parallel circuit. In a parallel circuit, in every circuit, the voltage will be the same. Okay, now there will be instances when it's not the same even though it's in a parallel circuit. Now that's advanced level, but this is just the concept. Now in a series circuit, however, Vs equals to VR3 plus VR4. So if I put a V here, and a V here, okay, these two voltages for R3 and R4 will add up to give you the voltage for S. Yeah? So this is the first formula you need to understand, your first concept. Now the second one, let's talk about the current. I have the current here, I1, this I2, I3. Okay, here I have, let's do this in, I don't want to use the same number, so I put I4, I5, I6, I7, I8. Okay, so let's look at the series first. Now, what you will realize that, see, because there's only one pathway, I1 equals to I2 equals to I3. What does this mean? This means that the current remains constant throughout the circuit. As long as it's a series circuit, the current remains constant throughout. Yeah? Now, for the parallel, what you will see is that here you've got current and it splits up, right? So I4 is equals to I5 plus I6. Yeah? Because the current splits up, so it will be equal. And you will also realize that I6 is equals to I7. Why? Because 6 and 7 is a series. From here to here, there's only one flow, right? So it's the same. The current will be the same. I8 is equals to I4, right? Because this one comes back in here, this one comes back in here, and joins back to form the same I8. So that is in a parallel circuit. So what you will realize is here in a parallel, the voltage remains constant. In a series, the current remains constant. In a series again, the voltage adds up. In a parallel, the current adds up. So it's kind of, alternate, it's interswapping. Now, let's go to the resistance. Okay? How do you calculate the total effective resistance of a circuit, whether it's series or parallel? Effective resistance meaning the total resistance of the circuit. Here, for the series, the total resistance is equals to R3 plus R4. You simply just add it up, right? Nothing too fancy. In a parallel circuit, okay, however, it becomes a bit complicated. You get 1 over R, which is 1 over the total resistance, equals to 1 over R1 plus 1 over R2. Yeah? So I'll just show you a very simple example here. Let's just say R1 was 2 and R2 was 3. Same thing here. This is 2 and this is 3. This resistance will be 5 ohm. Oh, I forgot to add that the unit for this is amperes. The unit for this is voltage. Yeah, unit for resistance is ohm. For the parallel circuit, however, it would be, I've got not much space over here, so I'll just do it in a different color. 1 over 2 plus 1 over 3 equals to 3 over 6 plus 2 over 6 equals to 5 over 6. Right? So 1 over R equals to 5 over 6. R equals to 6 over 5 ohm, which is equals to 1.2 ohm. You see the very clear difference in the resistance, even though we put in the same values, right? 2 and 3. 2 and 3 over here, 2 and 3 over here. In a series circuit, it's 5 ohm. In a parallel circuit, it's 1.2 ohms. So the thing is that in a parallel circuit, you kind of, the more resistance you add up, it tends to get lower. In a series circuit, it tends to get higher. Another advantage of having a parallel circuit over a series circuit is that in a series circuit, if, for example, instead of using resistors, right, let's just say you're connecting bulbs. If this bulb blows over here, I mean it fuses, this bulb here will not be able to light up. So imagine your house and one bulb blows. Because of one bulb blowing, the entire house is in a blackout. You wouldn't want that. And that's why most likely the lighting in your house is done via a parallel circuit, whereby if one bulb blows, the other bulbs can still light up. Yeah. Now this is the um, basic level concepts that you need for the calculations. Yeah, I hope you understand. I will be creating another video with a bit more advanced level calculations, a bit more of how to read the circuits and everything like that. And you should do that. You should watch that video too. And yeah, that's it. I hope you got it. Again, any questions, please comment below. And do like the video, do share, do subscribe, and yeah, take care. Bye bye.